Uh, Today I will be presenting about the paper called GAMED Knowledge Adaptive Multi Experts Decoupling for Multimodal Fake News Detection. This was proposed in Wisdom 2025 conference. I will follow this order for the presentation. To start with, fake news are defined as purposefully crafted, misleading, or fabricated information that mimics the form of mainstream news. And it can be in unimodal format or multimodal format. This study focuses on the multimodal fake news. They say that limitations in existing study can be summarized into four main topics that they try to cover in this paper. So the first one is they say the existing studies rely on basic fusion techniques, but most fusion techniques suffer from feature suppression issue. And feature suppression is when the features from individual modalities get overwritten or diluted when modalities are combined. The second one is relying on the capabilities of the pre-trained models um, too much without any refinement steps. Third one is focusing on the consistency between modalities, but not utilizing the discriminative features of the modalities. Last one is not considering how much each modality contributes to make the final decision. So their solution is a framework called GAMED, and it's based on model decoupling modeling, and it combines characteristics of expert networks and adaptive instance normalization to perform progressive feature refinement to obtain more discriminative feature representations. And they also demonstrate that external knowledge is beneficial to help models understand, classify fake news. And they introduce also a novel decision-making method as well. So if we see the related work, there are unimodal and they can be separated into two. First is unimodal fake news methods. They are significantly effective, but they struggle against multimodal fake news that blends different media. And second one is multimodal fake news methods. Common techniques that are used are advanced fusion models or external knowledge. But as I said, the challenges still remain. So they show poor generalization to new fake formats like deep fakes, for example, that appeared more recently. And they say that they lack of explainability in model decisions and focus heavily on fusion, but underuse the unique strength of each modality I mentioned before too. And this is the framework that they propose. And here you can see that there are four steps: feature extraction, expert review and opinions, distribution adjustment, and finally the decision making. First is feature extraction. So GAMED extracts features separately from text and images instead of combining them early on. For image modality, there are two kinds of image features that they look at. For first one, they use Inception ResNet version 2 with a special filter. This one is to detect the low-level manipulations in the images. And the second is to capture the semantic meaning of the image, both globally and locally. And for this, they combine VIT with masked autoencoder. And this helps the model to understand what's actually in the image and not just how it looks. So this is important for fake news detection. They also use some data augmentation methods to improve robustness as well. And for the text, they use ERNIE 2.0. It's a powerful language model. It's different because it uses knowledge graphs and understands text at sentence level and also the token level, I think. So they choose to use these. And the second step is expert reviews. This stage actually mimics how real experts would review a suspicious post. So they use expert neural networks, um, and each expert looks at different parts of the input and gives an opinion. So here the proposed method is called like this. It's actually an upgraded version of multi-gate mixture of experts, which is already an existing method, but they change it a little bit by uh, by using token level attention. So it focuses on the most informative parts of the input. And another change is removing the softmax constraint in gating. So uh, expert weights can be negative or larger than one, uh, which makes the model more flexible when it combines the expert opinions. And as I said, expert networks are for each modality, so text, image, and multimodal. The final defined representation for the fake news is weighted sum of expert outputs using the learned gates. This defined feature the refined representations are sent to the next stages. So the next stage is done using adaptive feature adjustment, ADA-in. So it takes each refined feature and adjusts its distribution using a learned mean and standard deviation value. And these values are generated based on the model's course predictions. So then the ADA-in formula you can see here normalizes the features and rescales them using the learned values. This step actually helps the model to highlight useful information and get rid of the irrelevant noise before moving to the final voting stage. And the voting stage that they propose is called Vero voting. Uh, so here, instead of simply just averaging predictions, they are applying a confidence-aware strategy for final decision. Um, so if one modality, if we say text, for example, is clearly confident, then we say that it should be allowed to override the other modalities. So, but if at the same time, if a modality seems unsure or noisy, then we should ignore it for the final decision. So for this to work, they first define each prediction scores for each modality outputs, and then they apply the sigmoid function to get a confidence score for the modality predictions. And then they define the high confidence and low confidence thresholds. The value for these thresholds is not mentioned in the paper. They just say that they define them. And then we basically use these two scores comparing to the thresholds to make the final decisions. I will explain here. So rule one is start here. It says rule one, but it's the starting point. So like think of it like step one. So we first start with the fused prediction. So P mix is the O mix is the fused prediction, and we apply sigmoid to it to get the initial confidence score. And then if a modality has higher confidence than P mix value, then it's above and also it's above the high threshold value. Then we replace the final prediction with that modality's output. A third rule is if a modality's confidence is below the low threshold and also it's in the majority class, then we ignore it because it's too weak to trust. And the last rule is if the confidence is between the two thresholds, then we just we just keep the original fused prediction, which is O mix. So this way we are making the final decision based on confidence weighted consensus, and we are preventing weak signals from dominating the decision. So they say this makes the decision making more interpretable and also stable. These are the experimental settings. They do the experiments on two data sets, faked it and young, and there are two labels. So labels are fake news or not fake news. These are the settings, and they use a lot of baselines, and specifically, some of them are specific for each data set. So the names are listed here. These are the results. So you can see in table one where they compare the GAMED framework to the state-of-the-art baseline that I just showed. The proposed framework shows consistently better performance on both data sets. And also, since LLM-based methods are getting more popular, they just choose and use specific LLMs like this and compare the performance. Here, direct is when there's no prompt to help the LLMs, basically, and chain of thought is there's a bit more help with the prompt. They don't share the prompts either for this task, but yeah, you can see the results here, and they also outperform the LLM-based fake news detection methods as well. So those are the main classification results, and they also choose 10 random real and 10 random fake news from the, I think. Yeah, from both of the data sets to show here. And the heat maps here show the degree of similarity between the features. You can see here between the fake news, features are more scattered than the real news features. So game still successfully captures these discriminative news features as well. You can see at the bottom of the image here. Uh, and the difference between modules reflect that each module can provide distinctive information when working, and this verifies the intuition that model decoupling can enhance overall detection performance as well. Here, the IS and IP are for image features, and T is text, and MM is the multimodal setting. They also do ablation study by removing each part. So removing the fusion model leads to major accuracy drop. And the text module performs the best individually, you can see here, stronger than the image-only setups. However, combining the text and image together improves the results, showing that cross-model synergy is important. And also removing the ADA-in and the expert neural network usage causes noticeable performance drop as well. So they are important in feature refinement and balance. And they replace ERNIE 2.0 with BERT model and the expert neural network with VIT as well, and they slightly hurt the performance as well. So this is showing that the external knowledge, I mean the knowledge aware and expert controlled refinement is important. And also without the Vero voting, the model is less robust to weak modalities. So to conclude, they introduce a novel modality decoupling framework for multimodal fake news detection, and they are trying to solve the problem of feature suppression in the usual fusion methods by using expert networks for selective feature refinement and ADA-in for adaptive feature adjustment and Vero voting for robust and interpretable decisions. They leverage also semantic knowledge from ERNIE 2.0 model, and they outperform the state-of-the-art models on the faked and young data sets. So yeah, this way they offer transparency and robustness and high accuracy. Yeah, thank you for listening. This is the end of the presentation.